Hello guys, welcome back to my channel, Mason African Motives. Still working on mathematics for N1 level. So in this platform we shall be working on the question paper which was actually written in August 2021. So we shall see how we are supposed to answer these questions. So actually, as you can see, you'll be given the requirements. In this case is to have a graph paper. A non-programmable calculator may be used. Okay, so we shall quickly see what we have on the instructions and information. That is the most important one, is to give the answer to 3 decimal places when you are rounding off, unless indicated otherwise. That is when you are given such a condition, then start each question on a new page. This one also is one of the most important. Okay, anyways, we shall be seeing this as we are moving, but let's just consider how are we supposed to answer these questions. Okay, so if you're new guys, you can consider subscribing to this channel so that you won't miss any of the classes that we shall be having from Mason African Motives. Okay, so let us quickly rush through the first question that we are given in this platform. So there we are given to simplify each of the following without a calculator by using exponential laws. Take note here, without a calculator, and you are using exponential laws. Okay, so what the first question, that's 1.11, which is a b to the exponent of 3 affected by exponent of a plus c multiplying b to the exponent of 3. All right, this one is affected by minus a minus c. So that is what they are testing us, guys. All right, so how can I simplify this? I have been talking about this law. If you have been watching our classes previously, I managed to talk about this concept where you are given an whenever you have an exponent like this and another exponent, that you're going to multiply the exponents. So that is the condition, because this 3 is an exponent, a plus c is an exponent, so 3 is going to multiply every term there. Okay, so let's see what you're going to have. So it's going to be b to the exponent of 3 times a, which is 3a, like this. 3 times plus c, which is plus 3c, like this. All right, we are multiplying to this part here, so it's the same concept. As we can see, 3 is going to multiply minus a, 3 also is going to multiply minus c, so this is going to be b to the exponent of 3 times minus a, which is minus 3a, 3 to the exponent of minus c, which is minus 3c, like this. So it multiplies everything. All right, then here we are no longer using this law, because this is now a condition where we are multiplying the bases which are the same. So we are using this concept now. Whenever you're multiplying the bases which are the same, you add the exponents. So that is the concept. X to the exponent of a times x to the exponent of b, it's x to the exponent of a plus b. So let's add, guys, and see what you're going to have. So you're going to have b to the exponent of 3a plus 3c, just like this. This is our a, which is this part here, added to this part here. So since you are adding, there's no need of you opening the bracket. You can just say plus. Let's see, so that you don't confuse each other, guys. So you're going to add. What are we adding? We are adding this, which is our b. So we're going to open a bracket for this part, which is minus 3a minus 3c, like this. All right, that is what we are having at this stage. Now we can expand our brackets. That's 3. This part will just remain as it is, 3a plus 3c. Remember, a plus doesn't affect, like, change. It's just going to remain as it is. Plus and minus, the minus is going to be minus 3a. Plus and minus here is going to be minus 3c. So that's what you're going to have. So this is the concept, guys. You can collect like terms. Which are the like terms that you're talking about? We have got 3a minus 3a. So this is simply 3 minus 3, which is a 0. So it's going to be b to the exponent of a 0. So this 2 actually is going to give us a 0 here. Okay, the same here, 3c and 3c is going to give us a 0 there. So 0 minus 0, that's a 0. And we know that any number raised to the power of 0 or to the exponent of 0 is going to give us a 1. So the final answer is going to be a 1 there. So these are the stages actually that we're supposed to have, and some of the stages you might not see them in the memo because they are working with the stages where they actually give you marks, but all the stage marks should be given whenever you're answering these questions. Okay, so these are the that's the part that we're supposed to have in this case. So let's see the other part again, still simplifying, but this time we are given another expression, and this time we've got 4 marks for that. Okay, so let's just write our question. That's 1.12 in this case, which is x to the exponent of 3 y squared being divided to yx to the exponent of 2 like this, times xy over 2 like this. All right, this is what you're asked to simplify. We all know this, guys, that if I am working with a division, whenever there is this sign here, a division, you can introduce multiplication. Let me just indicate this way. If you are dividing x being divided to y like this, okay, it is the same thing as writing it as x over y like this. It's one and the same thing. The concept of writing this and this, which came from x times 1 over y like this. This is where it came from. If you are dividing, you can multiply by 1 over y. So you can write this in this format or in this format. You just choose the best form. So this is what is happening here. So we can choose to write it as x to the exponent of 3 y to the exponent of 2 like this, over this part, or multiply by this part. So it's still like one and the same thing that we are having in this case. Maybe some of us might understand in this way: yx to the exponent of 2 like this, times xy over 2, which is still the same part like this, guys. So this part and this part is one and the same thing. I'm just saying what we have, or some can understand a law written this way or a law written this way. So that is why I'm talking about this. Okay, so what is going to happen? We know that whenever we are dividing, we subtract the exponents. Okay, so this x here is going to be affected by this x here, this x and this x. These are the ones that are dividing each other. So we're going to subtract. So it's going to be x to the exponent of 3 minus 2 like this, because we are dividing, which is going to give us x to the exponent of 1, which is the same as x. So here we are going to remain with x. All right, we do the same here for y here. This y and this y, they're dividing also. So you subtract, as you can see, it's 2 minus 1, which is going to give us y to the exponent of 1, which is the same as y like that. So that's what you're going to obtain here. Okay, you've applied the laws of exponents there. Multiply by x y over 2 like this. All right, this is the same as every whole number or every term. If you are given 2 like this, you can write this 2 as a fraction as 2 over 1 like this. You haven't changed anything. It's still one and the same thing. 2 and 2 over 1, which means a is the same as a over 1. So using this concept, it means this xy like this is same as xy over 1. So that means I can multiply, in this case, that's 1 times 2, which is 2. Then here I'm multiplying x to x, so it's x times x. which is you add the exponent. So it's 1 plus 1, which is x squared. Then you've got y times y here, which is 1 here and 1. So it's 1 plus 1, which is y squared, like that. So that is what you're going to have at the end. Remember, when you're multiplying the bases which are the same, you add the exponent. So that is why we are adding here. There is a 1 here, there is a 1 here. Every term like 2 is the same as 2 to the exponent of 1 in terms of exponents, but in terms of fractions it is same as 2 over 1 in terms of fractions. Then in terms of exponents, so these are two different things, but it's the same 2 which can be expressed in exponents or in as fractions. Okay, so that is what we had, guys, from this one. So as you can see, all you actually need is to revise much questions so that you can actually understand the concept there. All right, so simplify without a calculator. Again, here without a calculator, by using logarithmic laws. This time we are working with logarithmic laws. Okay, and the first question is minus 5 log 1 over 25 in base 5, and we've got 4 marks for that. Okay, so let's see what we're supposed to do in this case. We have got negative 5 log 1 over 25 in base 5, like this. All right, so this is the concept. There are so many ways actually of answering this question. So what I can actually do, this is a 1.2. So what I can actually do is this. There are so many ways. Okay, let's start with the fraction first. 1 over 25. All right, 1 over 25, like this. We know that from our laws of exponents, it's the same as 25 to the exponent of negative 1. Okay, take note, logarithms and exponents, they work hand in hand, they work together. All right, so this is the same as 25 to the exponent of negative 1, like this. All right, which I can actually write in terms of 5. Okay, maybe not to rush. Let's write this minus 5 log 1 over 25, which is this part here. I'm going to do it stage by stage so that we don't miss each other here. So we're going to write this like this: 25 to the exponent of negative 1 in base 5. So we have taken rid of the fraction first. Okay, then what do I have? Not to confuse you, just take off this negative. Okay, how do you take off the negative? You multiply it here, because you know from this concept, log m to the exponent of p is same as p log m. So we can multiply this to the minus. So it's minus 1 times 5, which is going to be minus 5 times minus 1 is going to be positive 5. So we're going to have 5 log 25 in base 5. Now we are left with something that is reasonable, guys. Did you see what happened here, guys? We said this one is going to multiply like it was an exponent like this, so it multiplies this number which is here. So that is what is happening. Minus 1 is going to multiply minus 5 like this times minus 1 like this, log 25 in base 5, because you have taken this minus 1 here. So this is the one that is now giving us a positive 5, this one. Okay, now this stage, what can I do with this 25? I have to write this 25 in terms of the base, which is what? Which is 5, because this is in its simplest form. So I'm supposed to write this 25 in terms of 5. So we know that 25 is same as 5 squared, like this. 5 times 5 is 25. So I can write this 25 in terms of 5 so that I can apply this law again. All right, so let's write this in terms of 5. It is going to be equal to 5 log, all right, in terms of 25, I'm going to write this as 5 squared. So it's going to be 5 squared like this, but we are still in base of what? We are still in base of 5. So as you can see, guys, we are now back to that exponent again. So we're going to drop the exponent just like what we did to minus 1. So it will be 2 times 5 this time. Okay, so 2 times 5, that is going to give us 10. 2 times 5, that's 10 log 5 base 5, like this. All right, which is one of the important stages that you're supposed to know in your logarithms, this one, I have been talking about this, and I told you that logarithm of a in base of a gives you a 1. Whenever you are given log of a number and a base which are the same, your answer is going to be a 1. So this is going to give you a 1. Okay, so this is going to give us a 1 here, so which means you're going to be left with 10 times 1, because 10 times log, and this everything is a 1. There's no log here, it's just a direct number which is 1. There's no log here. Okay, so which means you're going to be left with 10 times 1, which is equal to 10. So that is what you're going to have from this part. So when you are in exam, what you do is that you simplify this with your calculator. Okay, you obtain an answer which is 10. Then you are now working knowing that your answer is a 10. At least it is going to help you if you find a different answer here, that you're supposed to now go back and cross-check on your working where you have made an error there. So at least it can help you. All right, but that was the concept there on this log. Let's see another one that we are given here on 1.3 is now to solve for x without using a calculator. Take note, guys, without using a calculator. Okay, we want to solve for x. This time it's an equation. This one is an equation, guys. Log 5x minus 15 like this in base 5 is equivalent to 2 like this. All right, we want to solve for x. All right, if you are to cross-check properly, you will see that we are in logarithms and it is very, very difficult for us to solve for this. So there are two options actually that we have here. What is the first option? The first option is to rewrite this in let's rewrite in exponential form. All right, that's gonna give us something which is much better to work with. So how do I rewrite in exponential form? Remember, guys, I talked about this concept of log ABC, like this ABC, which is actually the same as A is equal to, remember, B to the exponent of C. So like this. So this is B to the exponent of C like this. So A, B, C, A, B, C, A, B, C. You can actually memorize using A, B, C. So it's log of A in base B is equal to C. Is the same as this A is equal to B to the exponent of C. So this is log form and this is index form or exponential form. That's exponential form. So that means I'm going to rewrite this as, if I'm to take this stage here, guys, if you are to see our A in this case, this one is our A, which is the number that is affected by log. So this is the number that is affected by log, this expression here. So my A is 5x minus 15 like this, which is equal to B, which is this B, the base, and B is our base here. So it's 5 to the exponent of C, which is the answer to the logarithm, and the answer to the logarithm is 2. So once I have an equation like this, I can solve because it's now a normal equation to me. Why am I saying so? Because 5 squared is same as 5 times 5, which is 25. All right, so that means we are going to have 5x minus 15, which is equal to 25. So just like a normal equation, as you can see, it's a linear equation, this one. So you can transpose minus 15 to the right hand side, so it's going to be a positive 15. So it's now 5x is equal to 25 plus 15, which is actually going to give us 30, which is a 40 then. All right, so we're going to obtain 40. Then to find x, what are we doing here? We are multiplying, so we divide by 5, we divide by 5. So this is gonna cancel. You don't divide by 40, you divide by the number that is affecting x here, because you want to find x. So you remove this number by dividing by it. Okay, so therefore x is going to be 40 divided by 5, which is an 8 from your calculator there. I mean, if you can just use it direct, because remember, not using a calculator, but At that stage, no one can even know that you have used a calculator there at dividing 14.5, so you can actually do that. So that is the first stage that we could have done this question. Or maybe you can consider this one, but it's going to be, you must be very, very careful when you are using this method. You must be very, very careful. You must be very, very careful. Okay, so this is another way of doing it. Maybe you don't want to convert to exponential form. You want to work this question in log form. You want to maintain in log form. That means we are supposed to now change this number here, which is 2, and convert it to a number which we do not know about, but that number is going to be in base of 5, because we are given already a log which is in base 5. So we are supposed to write this 2 in terms of the log in base 5 as we are given on the left hand side, so that we can equate these logarithms. So this one is going to remain as it is, which is log 5x minus 15 like this in base 5 is equal to, now we said we want to convert this log 2 in terms of log base 5. So this is what we have written here, log base 5. So we want the number that is going to affect here. How are we going to determine that number? Where are we going to have that number from? All right. This is the concept. We are given that the logarithm of this number that we want to calculate, let's say x, in base of what? In base of 5, is going to give us the answer here, which is 2. So this x is going to be 5 to the exponent of 2, which means our x is going to be 25. So that means here our number is 25. So as we can see, we have log of base 5 here. We have got log of base 5 here, so you can actually cancel this and equate these two, which is 5x minus 15 is equal to 25. So as you can see, we are back to the same equation that we had previously, that we had to solve for x. So this can be another option, but as you can see, guys, it needs you to understand the logarithm concept in depth. You have to understand it very, very well, so that you can be able to use it. But I think the first one is the best here. You can obtain your 15 marks. As you can see, guys, everything there easy to obtain these 15 marks, as you can see, guys. Then on question 2, divide this expression by x plus 2. As you can see, guys, these expressions, they are repeating, and I told you that the order should be this. You must write in terms of ax cubed plus bx squared plus cx plus t, like this. So the exponent should be 3, 2, 1, and a 0 there. So which means we're going to take this as 8 x cubed, like this. We have got x squared here, this one, plus 35 plus 35 x squared. All right, we need this one with x, which is 26x plus 26x, like this. And we need this -4, -24, like this. All right, so that is our expression that is going to be divided by what? By x plus 2. So remember, guys, how you divide, I told you, it's going to be x plus 2, which is dividing this whole expression, this one. Okay, seems like we've got a lot to do there. Let's see, guys, what we have here. Plus 26x minus 24, like this. All right, so this is what you're going to divide actually from the expression that we are given. So let's divide, guys, and see what you're going to have at the end. All right, because that's what we have here, guys, and we know that whenever you are dividing, remember the concept. Okay, let me just write 2.1. This is 2.1. All right, remember we've been talking about this, guys, is the first term always divide by the first term. So which means we are going to have this 8x cubed divided to x. So this is going to be over x, which is going to give us 8x squared. So you can see, guys, this is going to give us 8x squared. Right, and I told you that you're going to multiply everything here. This is going to multiply everything here, every term. Okay, so that is if you multiply, you're going to have 8 times x, 8x squared times x. That's going to give us 8x cubed, because this is x squared, this is x, so it's going to be to the exponent of 3. Then 8 times 2, which is going to give us 16x squared. 18 and 2, that's 16. Okay, so remember the concept, guys, that we are supposed to subtract this. Okay, so we have to subtract there. So as you can see, 8 and 8 is going to give us a 0 there, because these are same factors here. 8 minus 8, that's a 0. So you're going to have 35 minus 16. Okay, and 35 minus 16 is going to give us 19x squared. So we work with x squared and x squared. Okay, then you drop these down. You have to take these down, these ones. Okay, you have done subtracting, so you take these ones down. So it's plus 26x minus 24. You take them down like this. All right, let's go back and divide again, guys. 19x squared, you divide back again. So it's 19x squared divided by x. That's 19x, because we are dividing by x. So this and this is going to give us x. So it's going to be plus 19x like this. All right, it multiplies back everything. 19x and x is going to give us 19x squared. Okay, 19x and 2, that's 19 times 2, which is 38. So you're going to have 38x like this. All right, then still the same thing, guys, we have to subtract here. All right, so let's subtract and see what we are going to have at the end. All right, that's 19 minus 19 there. As we can see, that's going to give us what? That's going to give us a 0 there. Yeah, 19 minus 19, and we've got 26 minus 38. Take note, it's positive 26, so it's just 26 minus 38, which is going to give us minus 12x like this. Then what are you going to do? We're done subtracting, so definitely we have to take this down. All right, so if we take this down, it's going to be negative 24 like this. All right, then back again to the normal thing. Minus 12x divided by x. So it's now like this. Minus 12x, you're dividing by x. Always you divide the first term and the first term. So this is going to give us minus 12 there. So we're going to have minus 12. Okay, is that so? Yeah, that's minus 12 here. Then it multiplies back everything. So it's minus 12 times minus x here, which is negative 12x. We do the same. It's minus 12 here times 2. This is a plus 2 here. So if it multiplies this, minus 12 is going to be minus 24 like this. So as we can see, guys, yes, we have to subtract, but these are the same terms. Okay, these are the same terms that we're having here, this one and this one. So definitely someone is going to obtain 0, 0 there. So that means after dividing, this is what you're going to have as the answer there, which is on top. And this, as you can see, it actually means x plus 2 was a factor. I've been talking about this, that when you divide and you obtain a 0, 0 like that, it means it was a factor, and the factor does not leave a remainder. That is why you obtain a 0 like that. All right. Then we are given to subtract from this expression. Subtract from. Take note, whenever you are given from is the one that you start with. Okay, that is the one that you start with. From, always from. So this is from this expression. So it is going to be 2.2. What is the expression? This one, as it is, guys, which is 7x squared minus 3xy like this plus 9y squared. From this, we are going to subtract. What are we subtracting? This expression here. is the one that you're going to subtract. Take note, guys, from this expression here, we are going to subtract this. So it's going to be this as it is in a bracket, minus 17xy minus 3x squared plus 13y squared. So you just write that part, this one, as it is, okay? Just write that expression, take it as it is. So that's the concept. So as you can see, there's a minus, guys. This minus is going to affect everything. That's what a minus does. So the first part here has nothing to do with this bracket, so that is why you just rewrite as it is. It has got nothing to do with the bracket, but this bracket is going to be affected by minus. So this minus is going to affect every sign inside the bracket. Okay, so that's minus and minus, that's a plus. We've got 17xy like this, minus and minus, that's a plus, which is 3x squared, minus and a plus, which is a minus 13y squared there. All right, so that's what we are having, guys. We have to collect like terms here, guys. Let's collect like terms and see what you're going to have. All right, we have got a x squared here and x squared, so that's 7 plus 3, 7 plus 3, which is 10x squared. All right, then we move on to another like term. We've got minus 3xy, this one, and 17xy. These are like terms. We've got x and y. So minus 3 plus 17 from your calculator is the same as 17 minus 3, which is actually going to give you, that's a 14 there. So we are going to have 14xy like this. All right, then we move on to this one, 9y squared and minus 13. So it's 9 minus 13, which is going to give us 4 minus 4y squared. So it's going to be minus 4y squared. Take note, guys, this one is going to give us negative 4y squared there. All right, so that's a negative there. 9 minus 13, which is going to give us a negative 4. So that's actually what how you answer these typical questions. So you must be very, very careful the way you attempt these questions. What are you subtracting from which expression? So this is always from. That is your first expression that you're going to write. Always the one that is written from. Okay, I think it is much clear. So which means if the question is to say subtract like this, subtract minus 3 from 4 like this, take note, subtract minus 3 from 4. That means we are going to take this from this value. So it's going to be 4 minus, what are we subtracting? We are subtracting minus 3. So you're going to subtract minus 3 like this. So it's 4 minus what we are subtracting this, so which is going to give us a 7 there. So that's the concept, because it's just like 4 plus 3, which is a 7. So you see, that from is very, very important. Never take that from for granted. It's very, very important. Then remove the brackets and simplify. This is what we have. Remove brackets and simplify on 2.3. That's 3 into x plus 1 into x minus 2. So there we just need to expand, guys. All right, so there are two options actually that we have. We can choose to leave these 3 outside the bracket and first expand what we are used to, which is this bracket. So it's going to be x and x here, which is x squared, x and minus 2, which is minus 2x. Okay, we are done with x. It is multiplied every term. Remember how you multiply, guys. Then you move on to this one. Is going to affect x, so it will be plus x like this. Plus 1 is going to affect minus 2, which is minus 2 like this. All right, so our 3 is still outside of the bracket. Let's just write it like this. All right, into x squared y, because we've got like terms to simplify here in the middle. So this one is same as 1 like this. So it's minus 2 plus 1, okay, which is actually minus 1 from the calculator. So it's going to be minus x. Minus 1x, guys, is just same as what? Minus x, minus 1x minus x, and we've got minus 2, which is just there. So that means we can now expand by this 3. So it's 3 times x squared, which is 3x squared, 3 times minus 3, which is minus 3x, 3 times minus 2, which is minus 6. So you can actually leave your answer like that. Remember, the question was to remove brackets, so which means our answer is supposed to be in a simplified version like that. So that's how they ask these questions, guys, and how you're supposed to answer them. Okay, on question number 3.1, fully factorize the following expressions. Okay, so that's 3.11. We've got 4 terms there, and I talked about this type of factorization. Whenever you are given 4 terms, guys, this is the concept. Whenever you are given 4 terms, you have to make sure that you group them into 2. All right, so you have to make sure that you group them in a way that you can actually factorize them. All right, so let's just see if we can group these terms into 2. All right, here, as you can see, 7 is common here, and here b is common. So we can actually do something here. We can factor out 7 here. All right, let's see if we group this into 2 like this. Let's put it this way, divide it into 2. All right, so that's gonna be 7 here, because 7 is the highest common factor. So if I factor out 7, is 7a like this, divide by 7. Remember, guys, how we divide this, 7a divided by 7, which is going to give us a. So you're going to be left with a. That's 14 divided by 7, which is plus 2 like this. All right, so remember, the concept is that what you're going to factor out on these 2 remaining terms, it must be the same as this. The bracket that you must obtain should be the same as this one that you're given here. So definitely this is a positive bracket. As you can see, everything here is positive. So it means whatever that you're going to factor out here must make the bracket a positive. So which means I'm going to factor out a negative, so that this bracket will be a positive. But also b is common here, so I'm going to factor out minus b like this. So the moment I factor out minus b, is going to be minus and minus, that's now a positive. B and b will cancel, which means I'm going to be left with 2 like this. Here, minus the number that you factor out is the one you have to divide it. So it's like this, minus ab like this, divide by minus b. So as you can see, this will cancel, this will cancel. We are going to left with what? With a. So it's going to be plus a. Take note, guys, 2 plus 3, 3 plus 2 are the same. There is no difference here. They are all positive. So it's the same here. A plus 2 and 2 plus a are the same. So that means these brackets are the same. So I'm going to factor out one of these brackets because they are the same, this one. So if I factor out this bracket of a plus 2 here, what am I going to remain with? I'm going to remain with a 7. Here I'm going to remain with minus b like this. So that's what I'm going to have at the end. So it's going to be a plus 2 into 7 minus b. So that's how you factorize, guys. You simply consider the type of expression that you are to factorize. Is it a linear or a quadratic or whatever that you're given, but you have to factor out the highest common factor. All right, which is the same as this one, but this time is different because here we have got 3 terms, so it's actually much different here. Let's just write it and see what we are given. All right, we are given something like this, minus 18 x squared y to the exponent of 3z like this, minus 36 xy squared. All right, so remember here we have to factor out the highest common. We have to find the highest common factor is the one that you're going to factor out because you're given 3 terms this time. Take note, guys, this time we've got 1, 2, 3 terms. So there is no way of grouping here. You have to just factor out the highest common factor throughout here. So let's start with the numbers. We've got 9, 18, and 36. So 9, that's the highest number that we can factor out. Okay. On these terms which you've got letters, which have got exponents, this one, do not worry about the highest common factor. You just take the one with the smallest exponent. That is the one with the smallest exponent. That will be the highest common factor as long it is common throughout, like this x is common. So you're going to take this one as our highest common factor, which is x. Okay, you move on to y. Is y common? We are going to take this y. We've got y here, here, and here. Which one has got the smallest exponent is this one, y squared, like this. You move on to z. Z here, but here we do not have z here. It's not there. So which means it is not going to be part of the highest common factor because it's not common throughout. So this is your highest common factor that you're going to factor out. All right. Now we are going to divide, guys, because we've got the highest common factor 9 divided by 9. It cancels x to the exponent of 3 and x. This one is going to give us x squared. Remember, guys, we've got 3 here and we divide by 1. We're going to be left with 2. Then here it's y to the exponent of 4. Divide by y to the exponent of, there are 2 here. You divide into these 2. So you simply subtract 4 minus 2, which is y squared. And z has got nothing to do with this part, so it's just going to remain as it is on this part. All right, we move on to this part. We've got minus 18 divided by 9, which is going to give us minus 2. 18 divided by 9, that's 2, but there's a negative there. X squared divided by x, so it's going to give us x. Y to the exponent of 3 divided by y squared, so if you subtract 3 minus 2, it's going to give us 1, so it's going to be y there. Z has nothing to do with this part, so it's going to remain as it is again. All right, then we have got this part, minus 36 divided by 9, which is actually going to give us minus 4, but x and x are the same, so they can actually cancel each other. Y squared cancel each other again, so this is just going to give us minus 4 like that. So as you can see, guys, that is how you factorize. So factorization, it's a concept type of a question which you are supposed to know the concept to use or to apply. Once you know the concept to use or to apply, you are good to answer any question that you might be given, guys. As we can see, that's how they actually ask these questions. All right, so another question is to simplify time, and we've got on 3.2, which is, you've got 5 marks for that, guys, to simplify this 3.2, which is 3 over 4x squared like this, plus 1 over x minus 5 over 8x like this. Okay, so remember, guys, that whenever you are subtracting or you are adding, you have to find the LCD, which is the lowest common multiple in this case of these denominators that you are given, and you do not cancel it. It maintains as it is. So let's start with the numbers. What is the lowest common multiple between these two numbers? Which means you're going to take this 8, that's that, because every number can be divided by 8 into 8. Okay, then x squared here, so that is the LCD, which is the lowest common multiple. This time you take highest exponents, the one with the highest exponent when you are working with LCD. HCF, you work with the smallest exponents, but the LCM, it's vice versa. So you are going to divide. This is the concept, guys, of adding or subtracting. You divide this by the fraction, the denominator here. So it's actually 4. We are dividing 8 divided by 4. Okay, which is going to give us 2 like this. X squared and x squared will cancel, but you don't cancel it. You assume as if you are cancelling. So just going to be x squared and x squared, which is a 1. Whatever that you're going to have here is going to be multiplied by 3, which is already there. Plus the same thing, 1 is going to multiply the answer that you're going to obtain when you divide this 8x squared and x. So as you can see, it's going to be 8x squared divided by x. This is going to cancel, and this we're going to remain with 8x like this. 8x squared like this divided by x. So this is going to cancel here, which is x, or simply x squared minus 1 like this, which is x to the exponent of 1, which is x. So it's going to give to be 8x using laws of exponents if you want, minus 5, which is going to multiply the answer that you're going to obtain when you divide 8x squared and 8x. So as you can see, 8 and 8, that's a 1. X squared divided by x, we are going to remain with x. All right, so that is the concept there, guys. Then we can multiply, collect like terms. So it's 3 times 2, which is 6. 1 times 8x, this is going to give us plus 8x minus 5x. Do not cancel anything here, just write as it is over 8x squared. All right, never cancel anything. All right, then you can actually collect like terms whenever they're like terms, because you have got 8 and 5 here, so it's 8 minus 5. So you're going to have 6, 8 minus 5, which is 3. So it's going to give us 3x into 8x squared like this. So you can actually leave your answer like this, or you can just factor out, because 3 is common here. So you can factor out 3 here. 3 is common, so 6 divided by 3, that is 2. 3 divided by 3, you're going to be left with x like this, everything over 8x squared. So never cancel anything, or you can just leave your answer like that. That is what we had, guys. As you can see, these were the stages that we're supposed to take. So any errors that we have there, let's see on the comment section for any part or any other method that we can actually work or apply. So that's what we had, and the question is, determine the following from the algebraic terms on 3.3. These are the algebraic terms, the prime factors of each term. Okay, so we need the prime factors. Okay, so guys, let's just find the prime factors of these terms. Okay, we've got the first term, which is 30x, so this is 3.31. So we've got 30x to the exponent of 7, y to the exponent of 2, z to the exponent of 5, like this. Okay, so we know that in order for us to write this in terms of prime factors, we can actually perform the division here, where we've got 30, which are the prime factors of 30. So the smallest prime factor that we need to try is 2. So prime factors, remember prime numbers, guys, we are working with 2, 3, 5, 7. These are actually the prime numbers that you're supposed to target. Okay, 11 and so forth. Take note, 2 is a prime number, because you're talking about number that you divide by 1 and itself. So it's only 1 and itself. So 2, we only have 2 and 1 there. 3, we only have 3 and 1. So as you can see, these are the prime factors that you target. So the first one that we have to target is 2. But 2, is it going to work? 30 divided by 2, that is 15. Okay, targeting 2 again is no longer possible, because 15 divided by 2 gives us a decimal. So we are going to, it's not a factor, because a factor is supposed to give us a 0 remainder. That is, there is no remainder whenever you work with a factor. So you move on to another factor, which is 3. So you have to try 3 this time. 15 divided by 3, that is 5. Okay, we can't use 3 again. 3 is not a factor of 5. So what is a factor of 5? 5. It's only 5. So 5 divided by 5, that's a 1. So as you can see, 1, we are now left at a stage where 1 is not a prime factor. So we cannot use 1, 1, 1. So these are the numbers that we have, which gives us 30. So this 30 here is the same as 2 times 3 times 5, like this. Okay, times x to the exponent of 7, which was there, times y to the exponent of 2 times z to the exponent of 5. So that is what we are having in terms of, that is a product of prime factors. You are multiplying the prime factors there. All right, Then another one was 105. We had 105 x to the exponent of 3. That's x to the exponent of 3. Y to the exponent of 4, z, like this. Alright, so you have to do the same thing here for this 105. I don't know if it is going to be clear here if we put it here. Alright, let's just try. 105, so as you can see, among the prime factors, 2 cannot because there is 5 here. So you just try, even maybe in exam, you just try to see if it is going to work. 105 like this, divided by 2. As you can see, it's a decimal, it's not working. So you move on to 3. 105 divided by 3. As you can see, it gives us 35. So which means 3 is a factor there. So you can divide by 3, which is a prime factor, and we obtain 35. So as you can see, 3 cannot work because we are now at 35. 3 is not a factor of 35. Let's just try 35 divided by 3. As you can see, it cannot work because it's giving us a decimal. So you have to move on to 5. 35 divided by 5, which is going to give us 7. So you've got 5 here. 35 divided by 5, that's a 7. And 7 as a factor of, is just 7 like that. So this is what you're going to obtain. So these are the prime factors that we are obtaining from 105, which is 3 times 5 times 7. So this one is same as 3 times 5 times 7 times whatever that we are given here, which is x to the exponent of 3, y to the exponent of 4, and z. So that is what we are having for this term. So that was the first question there on 3.31 to just express as prime factors. Then the other question now is to determine the lowest common multiple, which is the LCM. So we need to determine the lowest common multiple, that is the LCM there. Okay, so what are we going to have as the lowest common multiple is going to be determined from these expressions that we have here. All right, so let's start with this. This is 3.32. All right, which is the LCM here. All right, so what is going to be the LCM? Remember LCM, guys, I told you that you take every term that is there. So as you can see, we've got 2. We're going to take this. So it's going to be 2. Let me just write it here. LCM is going to be 2 times. We move on 3. Yes, 3 is common. We've got 3 here. But we don't repeat these 3 because it's just appearing once on both terms. So you just take it once times 5. This one is repeating also. You don't take it once, you just write it. You don't take it twice, you just write it once like that. Okay, times. We also have 7. So you take every number that is there. That is the LCM. Okay. Then for these ones with exponents, remember what I talked that we take the one with the highest exponent. So in terms of x, this is the one with highest exponent, which is x to the exponent of 7. In terms of y, that is the one with the highest exponent, which is y to the exponent of 4. In terms of z, this is the one with the highest exponent, which is z to the exponent of 5. So LCM, you use the highest exponent. Okay, so what you need is now to multiply the numbers that you're given here, which is going to give us this. If you multiply everything, it's going to give us 210. Okay, that's 210 if I'm not mistaken there. Then this part you combine, which is just x to the exponent of 7, y to the exponent of 4, z to the exponent of 5, like this. So this is going to be your LCM. All right, then 3.33 is now the HCF. All right, so remember, guys, on the HCF, I told you that this is a common factor, so it must be seen throughout. A factor should be seen throughout here. A factor. Okay, so let's see the terms which are common throughout. Okay, as you can see, 2 is not there, so 2 is actually out. Okay, 3, we've got 3 here, we've got 3 here, so we're going to take this 3 times 5, we've got 5 here, we've got 5 here, so you're going to take this, that's 5, times Okay, 7 is not common because we do not have 7 here, so 7 is not common, so you're not going to take this 7. Okay, we move on to these terms with exponents. This time you take the one with the smallest exponent, so it must oppose highest common factor, smallest exponent. LCM, highest exponent. So HCF is the highest common factor, but it uses the smallest or the lowest, the one with the lowest exponent. So and it must be common. So this time we're going to take this x. Yes, x is common here, but we're going to take the one with the smallest exponent, which is x to the exponent of 3. Y is also common, but we're going to take the one with the smallest exponent, which is y to the exponent of 2. Z also is common, but we're going to take the one with the smallest exponent, that's z. All right, so once you know this idea, it can help us a lot to simplify these typical questions. So let's just multiply 3 times 5, which is 15, x to the exponent of 3, y to the exponent of 3z, which is going to be our HCF, like this. So these are the typical questions, guys, that they ask, and as you can see, we are having a total of 6 marks for that, and this question 3, 18 marks, guys, that we now have. All right, so that's how they ask these questions. Even in exam, that's what you're going to have. They're going to have questions like this: solve the following linear equation. That's a linear equation, but we've got brackets there to work on. So this is 4.1 that's 12 into y minus 3 minus 3 into y minus 9, which is equivalent to minus 5 into y plus 6, like this. All right, so that's what we're given to simplify. So as you can see, the first thing definitely is to expand brackets, guys. We have to expand brackets here. That's 12 times y here, which is going to give us 12y. 12 times minus 3, that's minus 36 there. Okay, minus 3 times y, which is going to give us minus 3y, like that. Okay, so this minus 3 times this, minus 3 times minus 9, so it's minus and minus, that's a positive 27. 9 times 3, 9 times 3, which is 27, guys. Okay, don't panic on this one. Minus 5 times y, this one is going to give us minus 5y. Minus 5 times 6, which is going to give us minus 30. All right. Now it's best for you to actually simplify the left hand side first. Collect like terms here, okay, which is 12y and minus 3. So it's 12 minus 3. That's 9. So this is going to give us 9y, like this, and we've got minus 36 plus 27, which is going to give us minus 9, right? 27, if I'm not mistaken there, which is minus 9 exactly. So this is going to give us negative 9. So we have collected this term and this term, which is giving us minus 9, is equivalent to minus 5y minus 30, like this. So at this stage, that is where now I can collect like terms to say from the other equation, from the other part of the equation, whenever it crosses the sign, it is going to change the sign into a plus. So that means we are going to have 9y plus 5y, like this, which is equal to the same with minus 9. The moment it crosses the equal sign to this side, it is going to be a plus 9 because it was a negative there. So we're going to have minus 30 plus 9. All right, let's see what you're going to have if we are to add the 2 here. That's 9 plus 5, which is actually 14. So this is going to give us 14y, which is equivalent to minus 30 plus 9, guys. This is going to give us something like what, 21. Minus 21, minus 30 plus 9, which is minus 21, like this. And we want to calculate the value of y. So what is affecting y is this 14, which is multiplying. Divide by 8 both sides, divide by 8 both sides. The moment you divide, you are cancelling these two. That means you're going to be left with y here. So therefore, y is equal to, you divide this from your calculator, which is going to give you minus 3 over 2. Or someone can just write this as a decimal, which is minus 1,5. Yeah, depending with what you want to write it, but that's your y there is going to be minus 3 over 2. So that's how they ask these questions, guys. Solving of equations for any unknown value, you have to be very, very careful. Expansion of brackets. So here we have to work on brackets here. So you have to expand or remove brackets. So you have to remove brackets. Then we have to collect like terms. Then from there we have to transpose. The moment you transpose anything that crosses the equal sign, it has to change its sign. That is the most important part about this. Then manipulate, which is on 4.2, manipulate the given formula to make y the subject of the formula. So we want to make y the subject of formula here on 4.2, where we are given ax plus y squared is equal to c. Let's transpose first. What is not affecting y is this ax. So transpose to this side of the equation, you're going to have y squared is equal to c minus ax, like this. Y squared is equal to c minus ax. So in this case, we've got a y squared. So take note, whenever there's a square, you remove this by introducing the square root like this on both sides, so that this and this will neutralize each other. So you're going to left with y is equal to the square root of c minus ax. And someone can just write this as plus or minus, since we know that the square root of a number is a plus or minus. So in this case, we do not know what is going to be the answer, but it's going to be a plus or minus like that, or just leave it like that. Use the answer in 4.2 and substitute the following values to calculate y. If x is 33, a is minus 2. So use the answer, which means from the answer, not from this part, but use the answer, that one that you calculate, this one, which means we are coming from this answer that we had on 4.2. And we have our answer was square root of y is equal to square root of c minus ax. So we are going to simply substitute now, because that is our answer that we had. X is 33 and a is minus 2. So in place of x, we are going to put minus 33 in this case. All right, so guys, there's a value that is missing here, because remember, we've got ax and we've got a c here, and we are only given x. So that is what you're going to have. Actually, you're supposed to substitute, guys. As you can see, our c is not there, so you're going to have c minus ax. Our a is minus 2, our x is 33, so it's minus a, which is minus 2 like this, times x, and our x is 33. So that is what you're going to do in this case. So I don't know, is it the value of c that is missing in this question, or when I printed this out, I don't know, but it's going to be a positive 66 like this. So if that c was there, then you just substitute the c here so that you can simplify. But as you can see, these are the only values that you're given. So if you're just given this, then that will be the value of y, which is square root of c plus 1, 66 like that. Okay, since we are not given the c there, because c was a letter which was there. Okay, that's what we have. At what speed did you travel if you took 8 hours to cover 9,000 kilometers? Yo, guys, 9,000 kilometers. Okay, so the first thing is, remember when you are given, this is distance actually, and this is the time, and you want to calculate the speed. So you know that speed is equivalent to distance over time. Always, this one is not going to change throughout. Let me just fix this like this. All right, so we've got 4.4 there, which is the speed, and it's always that speed is equivalent to distance over the time taken, which is the distance of 9,000 kilometers like this. We've got 9,000 kilometers over 8 hours, so you're going to have this in 8 hours. So it's a matter of dividing, guys. 9,000, which is being divided to 8. So if you divide this properly, you're going to obtain like 1,125 like this kilometers per hour. Guys, this is something else. 1,000 kilometers, 1,125 kilometers per hour. So that's what we have, guys. You have to make sure that this is kilometers. So formula speed is equal to distance over time. So this is actually distance here over the time taken. This distance should be kilometers and the time should be in hours. That's actually what you are supposed to understand or to know in this platform. All right, so that's it. Let's see another question. The difference between 15 times a number and 3,000 is 0. What is the number? The difference between 15 times a number and 3,000. So 15 times a number, we do not know the number. But let's just say the number in this case is x. So let x be the number. So let x be equal to the number that we do not know. All right. So if this x is representing the number that we do not know, and it's 15 times that number, that is 15 times x like this. So they are saying the difference between 15 times a number and this number. So which means it's either the other way, whether you're subtracting this from this end, but the case is just the same here that we are having. We are going to obtain a 0. So if we say x is the number, therefore if we subtract 3,000, that is the difference between these two numbers. 3,000 minus 15x, we must obtain a 0. So that means 3,000 we can now solve, because we are given that it's going to give us a 0. So we are going to solve 3,000 is equal to, transpose to this part, is going to be positive 15x this time. So this is going to be positive 15x. So to find x, because x is the one that is representing the number, so you divide by 15 like this. So this can cancel each other. So therefore x is going to be, if we divide this by 15, guys, that's 30,000. 3,000 divided by 15, which is going to give us something like 200. So this is going to be your x. So that's the number is 200. So that's the number. So like 15 times 200 was the number, guys. 15 times 200. Let's just prove and see. If you multiply to 15, you're going to obtain something like 3,000. That's what you're going to obtain. So as you can see, 3,000 from 15x, here it's 15,000, it's 3,000. So 3,000 minus from 3,000, that's actually a 0, as you can see. So that was the number, that was the number there. Then on question 5, we are asked here to write the equation in standard form. Okay, this one, guys, is like this. That's 5.1 like this. It's x over minus 2 like this, plus y over 3, which is giving us 1. So we have to write this in standard form, which is the standard form of y is equal to mx plus c. So we have to get rid of what? Of the fractions here. You've got a negative there, something like that. So that's what you need, which is to clear out this to make y to be the subject. So what can we do to make y to be the subject? That is the question. We can actually leave this y here, y over 3, which is equivalent to, on the other side, we're going to be left with if we transpose this to this side of the equation, it's going to be plus x, but it was a minus, so it's going to be x over 2 like this. Okay, plus a 1 which was already there. So in order for us to remain with y here, we have to multiply by x each and every term. So here we have to multiply by 3, which is the denominator here, so that this can cancel. You are left with y, which is equal, but this 3 is going to affect everything. So it's definitely, it will be 3 over 2x like this, plus 3. So that is the standard form, because 3 times x over 2 is the same as 3 times 1 over 2, which is 3 over 2x plus what? Plus 3. All right, then determine the gradient. So definitely, okay, this was 5.11, and we've got 5.12, which is in this case the gradient. So in this case, the gradient is actually the part that is affecting x, which is this part. That is 3 over 2. Remember, once you write the equation in the form of y is equal to mx plus c, m is the gradient and c is the y-intercept. In this case, the y-intercept is at 3. So that's 5.13. So the y-intercept is at 3, so which is going to be 0.3. as a point. So that's our y-intercept, which is the point 3. So that one is just to determine. Okay, given, write down the equation in standard form. Okay, so this one we talked about this, that is supposed to be written as y is equal to a over x, like this. Okay, so what can we do? We divide by x, so it's going to be y is equal to minus 3 over x. We just divide by x, that's the standard form. All right, so in which quadrants is the graph drawn? Okay, when there is a negative like this, it is going to be drawn in the second and fourth quadrant. It's going to be like this. When it is a negative, it's going to be like this. All right, when it is a negative, so it's going to be in the second quadrant and in the fourth quadrant. When it is a positive, that's where you see it here in the first and in the third. So this one is going to be seen in the second quadrant. So that's the second and fourth quadrant. So that is where we are going to see this fourth quadrant, like that. All right, then what is the name of the graph? Okay, so the name of the graph here, we are actually working, these are hyperbola. If you're working with a hyperbola here, so that's a remember we've got a hyperbola and a parabola and a linear function. Hyperbola, parabola. A parabola is the one that is a quadratic, the one with a quadratic form. But this one, we're having a parabola there. And we are now asked to, on 5.3, use the table method to draw the graph of y of 2y is equal to this. And we are given the domain, in this case from the graph paper. On graph paper, all values and points of intersection, a system must be shown. We must show all the values, guys, from -4 up to 2 to draw this equation here. All right, so let's start by working on the equation itself before we have the table here. Is 2y is equal to -4x, like this, plus 8. So guys, we can actually divide by 2 throughout here. Divide by 2, divide by 2, divide by 2, like this. So this can cancel. That's y is equal to -2x. That's going to give us -2x plus 4. So this one and the other are actually one and the same thing, with one that we are given of 2y is equal to -4x plus 8. Guys, this is one and the same thing here. All right, so we can actually create a table for this one because it's in its simplest form, so it is not going to strain us much here. So we just have to need our table, x and y. Remember, we are given the values of x to take from -4, but it's given, take note, its x is greater than -4, less or equal to 2. So here I explained this from one of the question papers, that if you are given like this, x is greater than -4, less or equal to 2. This one, take note on this part, you are going to start from -3. -4 is not included, but here we are going to end at 2 because it's less than or equal. There is an equal to here, so you're going to end at 2. So you're going to start with -3 and we end at 2. So it's -3. Remember, we'll be going this way: -2, -1, we move on to 0, we move on to 1, up to 2, like this. So these are the values that they want you to indicate and show on the graph paper, guys. So you must show all these values. All right, so what am I going to do from this is to just substitute this in my calculator. When x is -3, substitute -3 in this case here. So y is going to be, in place of x, we substitute -3 to be -2 into -3, like this, plus 4. So you substitute -3 here in place of x, which is going to give us a 10. So that's going to give you a 10. When x is -2, you substitute -2 here. That's -2 times -2 plus 4. okay, which is going to give you 8. When x is minus 1, you do the same. Y is equal to minus 2 into minus 1 plus 4 like this. So this is going to give you 6. When x is a 0, you do the same. You substitute a 0 here times this. You're going to obtain a 4. When x is 1, you're going to do the same again times 1 plus 4 like this. And this is going to give you 2. When x is minus 2, you do the same, guys. In place of x, you substitute 2 this time, which is going to give you a 0 like that. All right, so remember, guys, what I told you, that once the table is there, you mark your points on the graph, okay? Because you'll be having the x and y axis, those ones, you mark your points and you simply draw a straight line from there. So that is the concept that should be given under this platform. So you have to try by all means to apply the concept that we have there. Okay, on 6.1 we are given name 2 conditions for triangles to be congruent. Okay, so for triangles to be congruent, we talked about this, that they must name 2 conditions for triangles to be congruent. We can this have RHS, we can have side, angle, side. Okay, we can have angle side. So depending with what you'll be given. So there are so many conditions, but it's just to name. So it's right angle, hypotenuse, side, side, angle, side. That is working with on a condition that the sides should be equal, the angles should be equal. So that is what we are going to work with them. All right. Find the length of AC if AB is 60 centimeters, BC 20 centimeters. You want to calculate the length of AC. So as you can see, guys, this one you're going to apply your formula sheet where you are given the Pythagoras theorem. Remember, if you are working with the right angle triangle, you can apply the Pythagoras theorem, which says that c squared is equal to a squared plus b squared. So that's a right angle triangle, guys, and this is our c squared, which is this side. So we're going to have this and this. So we are going to have AC. Remember, we want to calculate AC, which is the one that is our hypotenuse here. All right. So AC squared is equal to the sum of these squares, which is 60 squared and 20 squared. So we've got 20 squared plus 60 squared like this. So AC squared is going to be 20 squared. So guys, there, I just encourage you to use your calculator there so that it can be much better. That's 20 squared, which is going to give us 400. So you've got 400 there, plus the same thing, you do it for 60 squared, which is going to give you 3,600 like this. Then you actually have to add these two. That's AC squared is going to be 4,000. That's what you're going to obtain in this case. All right. So to find this AC, because there's a square, remember how you remove the square, you introduce the square root like this. So the moment you are introducing the square root, you are neutralizing this exponent. So you're going to be left with AC, which is the square root of this. So if you are using a calculator, it must give you 20 square root of 10. Then you put it as a decimal. So as a decimal, you're going to have 63,2455532 like this, which is the same as 63,2. Remember, to 3 decimal places, 1, 2, 3. So it's going to be 2, 4, 6 like this. That will be our AC, because 5 is going to change this into 6. And the units there is actually in centimeters. We are given this in centimeters here, as you can see. Name the properties of an isosceles triangle. Okay, what are the properties, guys, of an isosceles triangle? You know, actually, in an isosceles triangle, the opposite sides are actually equal. It's all about this. That's an isosceles triangle, where this angle here and this angle are the same. All right, so that's what we are talking about here. So these are the properties that we have on an isosceles triangle. So actually, base angles are equal. Base angles are equal. And what else? The two sides are equal. Two opposite sides are equal. Two sides are equal. And what we have, there are so many properties. If in this one, there's we've got one line of symmetry. They've got one line of symmetry. All right, then what does it do? The line of symmetry bisects the line at 90 degrees. Oh guys, there are so many that you can list out there. All right, so that's how you answer these typical questions. But actually, a straight board ramp is being designed to cover a horizontal distance of 6 meters with an angle of elevation of 3 degrees. Find the length of the board ramp. All right, this is the straight board, guys. It's going this way, so this is where it is going, and it's covering an angle of 3 degrees, guys. And okay, let's just put this as a distance. Let's just put this as x. The distance here where the board is working with x. So according to these 3 degrees, this is what we have, guys. If you are working with this, I want you to see this part, the way that the triangle is put away, like this is how you are used to. But it's the same thing as we are given this side, which is we are given C in this case, this one, which is the opposite to 90 degrees. As you can see, we are given this as our C, and we are given this angle and a side that is on this one. So as you can see, this is the angle and the side, so which means we are given C and B, and which ratio uses C and B, which is the adjacent and the hypotenuse. This is the adjacent and this is the hypotenuse, which is B and C. So you've got B and C on cos, so you're going to use the ratio of cos. That is where we only have B and C, because this one is not given. We do not have, and we are not working with this side, so there's nothing that you're going to take here. Work with what you are given, what you want to calculate, and what you are given. That is what you work with. So you work with according to this angle of 3 degrees, that is cos theta. So we're going to use cos theta there. All right, that's 6. That's question 7 actually, and of course 7.1. So you're going to use cos theta, which is that's cos theta, guys, which is equal to B over C. So in this case, it's cos 3 degrees. Our theta, take note, guys, our theta here is 3 degrees. This one is 3 degrees, and this is our B, which is this side, and this our C. So our B is this 6. So it's 6 over C, our C, which is the one that you want to calculate the length of the ramp, which is this one, which you can just write it as X like that. Okay, so you have to calculate X. It's now an equation. Forget about trig, guys. The trig part did its part. Now forget about that. You are now back to normal equations. This can be put as a fraction so that someone can cross multiply here. So it's X times cos 3, which is going to give us X cos 3 like this degrees, which is equal to 1 times 6, which is 6 like this. All right, so to find X, which is the distance here, you have to divide, because here you're multiplying, so you have to divide by cos 3 degrees. You divide by cos 3 degrees like this. So this is gonna cancel like this, so that you're going to remain with the value of X, which is now this part here. So you just use your calculator to simplify that part that you're given, which is 6 divided by cos 3, just like this. 6, make sure that there's a D there, that one in degrees. Okay, so it's 6 over cos 3, which is cos 3 degrees. Then you just close your bracket like that, which is 6.008. All right, so this is going to give us something like 6.00823, something like that. And remember, to 3 decimal places is going to be 1, 2, 3, which is going to be 6.008. It's because of the angle. That angle is too small. Too small. Okay, but in meters like that. So actually that's what we needed in this case, and that's what we're supposed to do. That is your X, or the length of the ramp board. So therefore the length of the ramp board is 6.008. Simplify without using a calculator by using special angles. Okay, cos 30 over sine 60. Okay, let's go back to the special angles, guys, and see what you're going to have. In this case, that's 7.2. We want to simplify cos 30 degrees over sine 60 degrees. Okay, something is weird here. Let's see. Something is weird. Okay, these are your special triangles here. Special angles, I mean. All right, so cos 30 degrees, we are given, this is our 30 degrees here, and according to cos theta, which is this one, theta, it's b over c, which is adjacent over hypotenuse. So this is your b, this is according to this angle. You're referring according to this angle. This is your adjacent, and this is your hypotenuse cos SOHCAHTOA. Okay, so cos that is going to give us the square root of 30 over 2. Square root of 3, guys, square root of 3 over 2 like this. Okay, everything over. We move on to sine 60. This time we are working with this here. So as you can see, sine it's a over c, which is according to theta. If this is theta, it's here over here. But now we are working with this theta this time. So this will be our a. So it's opposite. This is now your opposite, this one. As you can see, the way it was opposite. So this time, this is our opposite. So 60, its opposite this time is this one, which is square root of 3. So it's going to be square root of 3 over the hypotenuse, which was c. The hypotenuse does not change because of the angle. It's going to remain as that, which is 2. So this is what you're dividing, guys. As you can see, this is one and the same thing. So it can actually cancel and give us a 1 here, because this is one and the same thing here. So it cancels each other, which is going to give us a 1. Or you can write this as square root of 3 over 2 times. The moment you multiply, you invert the fraction like this. So it's going to be 2 over square root of 3. So that this can cancel, this can cancel. You remain with a 1. So that's how they test you, guys, just to test you to see that can you apply, just can you be able to apply the angles, only the application. That is what actually they will be asking you there. So that's how they ask these questions, guys. And let us see the other question to make it up on question 8, which was given AB. We're given the dimensions there of a parallelogram. Take note, this is a parallelogram. Calculate the area of the parallelogram. Okay, so always, guys, for these ones, you'll be given the formulas. That's the area of a parallelogram here. It's base times perpendicular height. That's the area. So in this case, you've got the base 2,5 and the height here, which is 1,8. So that's the area. So 8,1 area is base times the perpendicular height like this, which is the base 2,5. That's our base 2,5 times the perpendicular height, which is 1,8. All right, so this is what you're going to have. 2,5 times 1,8. That's 2,5 like this times 1,8, guys, and this is going to give us as a decimal. Just use this to change to a decimal, which is going to give us 4,5. So this is just 4,5. And what are the units here? We are working with centimeters. So this is going to be square centimeters. All right, so that's our area. The illustration shows a right triangular prism, okay, with the following measurements. These are the measurements that you are given, guys, here. All right, and an angle here of 90 degrees. As you can see, it's right angular, which means also you have got 90 degrees there. The question is calculate the perimeter of triangle ABC. Okay, that's A, B, C, this one. Take note, guys, this side here, from this side to this side to this side are the same. Also, this one from E to D, this one is the same as from A to C. Guys, take note, these ones, they are the same here. A to C, and this one E to D, these ones, they are actually the same. So this one is going to give us 21 meters also. So which means perimeter, remember, guys, perimeter is distance right round the shape. That is the perimeter. So this is 8.21. So perimeter, you add everything around the shape. So your perimeter is going to be 4 plus 21 plus this. So you add everything. So it's 4 plus 21 plus 20,616 meters. So you add everything that is around there. Okay, so we said 4 plus 21. So that's going to be 4 plus 21 plus 20,616. 20,616, which is going to give us as a decimal 45,616. So this one is going to give us 45,616 in meters. So perimeter add, okay? Then we are also given the area of rectangle A, B, C, D, E. Okay, that's A, B, the rectangle A, B, C, D. That is what, so A, C, D, E. I'm wondering what's happening here. A, C, D to E. This one, that's the rectangle that we are given. So as you can see, these are opposite. So this is going to give us 12 meters, 21 and 21. This one, the part on top there is a rectangle, and area of a rectangle, that's length times breadth, or length times width. Okay, so that's 8.22. So the area, so this one is going to be length times breadth. So it's for this ACDE, which is ACDE, which is 12 times 21. So it's going to be the length 21 times 12 in this case. So you simply, area guys, you simply multiply. As you can see, it's a matter of applying the formula, but this will be there in your formula sheet also, which is 252 square meters. So when you are given a rectangle, as long as you're working with a rectangle, area is length times what? Length times breadth. So that is what you are given, guys, and what you are supposed to know for this one. All right, so that's what we have there. Then another part is calculate the volume of the prism. Okay, we have to calculate the volume of the prism. So in this case, what we are given, or what we see on the other side, in this case we can actually, it's a right angular prism, so you can actually calculate the area of this triangle. Remember, when you are working with this one, it's a right triangular prism, so it's the area of the triangle times the length. So this half BH here is the area of the triangle, not the rectangle. Okay, so that's what we have here. So the volume is going to be the area of this triangle times the length to the other side there. So the area of the triangle is half base and perpendicular height, like this. Let me put it this way, 8.23. Okay, so volume, we said it's half BH, half base times perpendicular height times the length. So it's going to be, oh guys, this is half BH, all right, which is half times the base. This is your base according to the triangle, 20,616. Okay, times the height. This is our height here. We've got a height of 4 meters there, times the length, and which is from this side to the other side here, which is 12 meters. So like the cross-sectional area actually times the height. That is the concept if you are to actually cross-check here. So that's going to be 20,616. Or let's just put it this way, half of 20, we just put it this way, half, which is 1/2 by 20,616, which is 616 by 4/12. That's 4/12, like that. You just put it on a calculator, which is going to be as a decimal, and it's already to 3 decimal places, so there is no need for you to round off. This one is already in meters, and this is volume, which is measured in cubic units, and these are actually meters, is going to be cubic meters. And this one, guys, I'm not seeing what is written here. Tabo wants to buy a cell phone at the beginning of the month. Month cost 12,000 is when the Tabo family got the salary at the end of the month. The cost of the phone was, calculate the percentage did save. The percentage of money did Tabo save. Okay, so in this case, guys, we have the cost. Let me just write it down here because it's not clear. I don't know what happened when I was printing there. It's 8.3. The phone that you wanted to buy was, I don't know if it is clear, the one that I'm having, but I want you to see how you answer the question. Is 12.588.00. This is the cost of the phone that you wanted to buy. Then now, the day that you wanted to buy it, you got it on sale. Okay, then you got it on sale at 10,999.00. Okay, so that is the price now. Then the question is, what percentage of money did Tabo save from what he had? So in this case, he wanted to buy this, which means this is what he has in his pocket. But when he's reaching there, he's now finding at this amount. So it's just going to be 10,099 like this over what you're given, 12,588 multiplied by 100%. So what is going to be the percentage? Or you find the difference first. Okay, still it's one and the same thing. 10,999 like this over the other one is 12,588. That's 12,588. Okay, multiply by 100%. So if you multiply by 100%, actually you're going to obtain 87 point. So which means the phone was now at 87.377%. So what did he save from this? Okay, this was at 100%. Now when he is to buy, is finding at 87.377%. So what did he save? You simply subtract the percentages. So it's going to be from minus 100. So you subtract there, which is going to be 12.623%. So this is what he saved. So Tabo saved. Is it Tabo or is Tato? It's Tabo, this one. Okay, so Tabo saved 12.623%. That is the percentage that he actually saved from what he was supposed to buy that phone, and now you got the phone on sale. So as you can see, guys, that's what you had. I hope that value was the same, because like I was saying, value is not, but that's the working day, and you've got 11, which makes it actually a total of 100 marks in this platform. So guys, that's it, and that's how they ask these questions on mathematics N1. So you need to work with much question papers and revisions so that you'll be able to understand how they ask and how are you supposed to answer this typical. So if you have a question paper actually that you want us to work on, okay, let me know on the comment section so that we can work on that question paper as a full paper, not a question from a question paper, but a full paper that you want us to work on so that we can work on it. So that's it, guys, from this question paper that we had from Mason African Motives. Till we meet again.